Hi everybody, this is Dylan Skybrook. This week I'm going to talk about catalytic probes as that's part of your forum question this week, catalytic probes. So I want to make sure the concept is clear, partly so you can get the question right, but also because it's a really important strategy for dealing with complex systems. The idea of a catalytic probe is that it's a small experiment that gives you some information about the system that you're working with. If the experiment goes well, you can amplify it. If it does not go well, you can dampen it or abandon it. A probe is something that gives you information, right? You do something to find out. You know, we send probes up to Mars or whatever so it can give information back to us. A catalyst is something that causes something to happen. So a catalytic probe is an experiment that gives us some information. The other thing about that then, as you'll read in the module and see in the question, is we want it to be safe-fail, which is a play on the words fail-safe. Fail-safe means it can't fail, or something that shuts everything down if it fails, something like that. In this case, we want safe fail. We want experiments that it's okay if they don't work, because we don't really know what the best thing to do is yet. That's why we're doing an experiment. So we want to do an experiment that isn't going to ruin everything if it goes badly, that we can amplify it if it works and dampen it if it doesn't. And so a catalytic probe then is really different from coming up with a good idea. For instance, if you decide to power Umore Park with renewable energy, that's a fantastic idea. Renewables have been tested over many, many years. These days, the price is comparable with fossil fuels in many situations, especially if you take into account external costs like health, etc. So renewables are great. They are not, however, a catalytic probe. Because if you were going to power Umore Park, let's say with solar, you'd have to build the whole infrastructure. You'd have to put all the panels up, you'd have to get all the wiring, you'd have to get the batteries, all the things that run everything. There's no experiment there. You're just doing a good idea. So it's not really a probe, for one thing. You're not getting information back. And it's also not safe-fail, although in this case we know that putting solar up is a pretty good idea. You have to do the whole thing, and then if it goes badly, you know, it's not safe-fail because you've already built it all, you've paid all the money, everything like that. There is a way that you could lay it out that is safe-fail. That's kind of a catalytic probe. And that's if you said, we're going to start with solar on just City Hall, and then we'll move it to other government buildings, and finally to residences and businesses. You know, kind of expand it stepwise. That's a possibility. Still don't use that. It's not a good enough idea. I want you to come up with a better experiment. But that's the kind of way that I want you to think of. You know, what's an experiment? How can I start small? Something that'll be bigger later. And I'm just using renewables as an example. There are many other good ideas that are also not experiments, that are not catalytic probes. So we want to figure out things that can be scaled up if they work and abandoned if they don't work. And the reason this concept is so important is that when we come up with plans and just apply them to complex systems, they often go awry because complex systems are complex. They move around a lot. They don't just stay still and let the plans just stay there. So it's good to figure out how to experiment with the complex system, to be in relationship to it, and really to let whatever solution you come up with build organically. So even in this paper that you all are writing, the design that you're coming up with for Umore Park, because it's theoretical, you're not actually at Umore Park, you can't quite do that. But I still want you to imagine it. I want you to imagine what it would be like to start small and then have the possibility for scaling up. The practice of doing small experiments is a form of listening. And so there's some humility there, that we have to be humble enough to do the experiment, listen to the information, and then respond in that way. And this kind of practice helps us evolve solutions. and to do that in relationship rather than just conceptualize it separately, and like I said, just put it on the system. And when we do just put it on the system, it's more likely to have unintended consequences. When we do it in relationship and when we evolve slowly, it's more likely that the solution can be integrated into the system and therefore be something that can be good over time and not just be good for a little while and then go amok. So one last thing, do not use community gardens as one of your complex probe examples. That is too easy. Everybody does it. I want you to dig, so to speak, a little bit deeper for some good experiments. Make us go, oh yeah, that's a good experiment. So that's it for this week, catalytic probes. Thanks.